Hi there. This video is an exam paper walkthrough of the Eduqas GCSE Mathematics Higher Tier Component 2 paper from summer 2022. This paper is worth 120 marks in total, and this is the fourth video of 6. It will focus on questions 14 to 17, which account for 19 of these marks. Eduqas Component 2 papers are calculator papers, so a calculator should be used. A little disclaimer: there may be more than one way to answer a question. The methods shown in this video are not the only way some mathematical skills can be applied. Okay, let's get started. Question 14. Simplify, and then we've got a fraction expression there with indices involved. So we're going to use our laws of indices. So the first thing I'm going to do is I'm going to simplify the top of this fraction, guys. So we have a bracket to a power. So that means it's a power of a power rule. So everything inside this bracket, whatever its power is, we're going to multiply it by 5. If it's a number, if it's a constant, we evaluate that. So the first thing we're going to do is 5 to the power of 5. And then it'd be x squared. So it would be x to the power of 2 times 5, which is x to the power of 10. And then it's y to the power of 1 times 5, which is y to the power of 5. We've still got y to the power of 6 on the bottom. I've not done anything with it. I'm going to evaluate 5 cubed because I can do that. So 5 cubed is 3,125. And then we've got x to the power of 10, y to the power of 5, all over y to the power of 6. So now we've fully simplified the numerator, we can work with what's on the denominator. So this is a division, remember. The law of division says that if we have the same base number, we can subtract the powers. Well, we have y here, so that's the same base number, so we can subtract the powers, okay? So y to the power of 5 subtract 6 means we're going to have y to the power of 1 left on the bottom. And you can write it like that, or you could say it was 3,125 x to the power of 10 y to the minus 1, because 5 take away 6 is minus 1. Either of those is going to get you that answer. Mark. (15a). Jim squeezes 1 pink grapefruit. He obtains 250 ml of juice, correct to the nearest 50 ml. Jim thinks he will obtain a maximum of 900 ml of juice if he squeezes 3 pink grapefruit. Assuming each pink grapefruit is the same size, is Jim likely to be correct? Yes or no? Show how you decide. So we're not going to tick yes or no. We're going to do some working out and then we're going to make a decision. Okay, so 1 pink grapefruit gets him 250 ml of juice to the nearest 50. Okay. So let's find the upper bound and the lower bound for 1 pink grapefruit, okay? So if it's to the nearest 50, 50 divided by 2 is 25. Oh, I've done that wrong. 50 divided by 2 is 25. So for our upper bound, we add 25 on. So the maximum amount of juice he could get from 1 pink grapefruit would be 275 ml. For the lower bound, we would take it off, okay? We're interested in the maximum he would get if he squeezes 3. So we want to go with the upper bound because that's the most he'll get for 3. So let's do 275 times 3. So 825 ml if we had the maximum juice from each of those 3 pink grapefruits. So he says he'll obtain a maximum of 900 ml. No, he won't, because even with the upper value, we're still slightly below 900, so we're saying no there. Part B. The mass of a red grapefruit is 150 grams, correct to the nearest 5 grams. The mass of a lemon is 85 grams, correct to the nearest 5 grams. The total mass, correct to the nearest 5 grams, of this red grapefruit and lemon and an orange is 370 grams. Calculate the minimum mass of the orange. Okay, so we are working with upper and lower bounds again. So we're working with grapefruit, lemon, and then at some point we're going to be working with the orange as well. So let's deal with the grapefruit. Okay, so we're going to do upper bound and lower bound. Nearest 5 grams. So half of 5 is 2.5. So upper bound we would add 2.5 on. Lower bound we would take 2.5 off. My brain doesn't want to work today. So the lowest weight the grapefruit could be is this, and the highest it could be is this. We're going to do the same with the lemon. So upper bound and lower bound. Again, to the nearest 5 grams. So we're adding on and taking off 2.5. So it would be 87.5 for the upper bound of the mass. And then 82.5 for the lower bound. Okay, so the total mass correct to the nearest 5 grams is 370 grams. Okay, so we're going to do the total mass, and we're going to get the upper bound and the lower bound of this too. So to the nearest 5 grams, so 2.5 either side again. So the upper bound is 372.5 grams. The lower bound is 365.5 grams. Okay, so we want the minimum mass of the orange. So the minimum mass of the orange is going to be the lowest total mass. Okay, oh. Question 16. As part of an experiment, 2 groups of people, A and B, took the same general knowledge test. The test had a maximum of 100 marks. Part A, the first 2 columns of the table summarise the results of the test for 45 people in Group A. Complete the cumulative frequency column. So cumulative frequency is a running total. So we started with 0 and then we added 3 to get 3. Now we're going to add 20. So that gives us 23. Now we're going to add the 15. That gives us 38. And then we're going to add 7. Which gives us 45, and this is what we'd expect this to be because it's for 45 people. So that's the cumulative frequency column complete. Part 2. Explain why 60 is a reasonable estimate for the median mark. Okay, so the median is the middle. We have 45 people, so 45 plus 1 divided by 2. Because 45 is an odd number, we add the 1. So we're doing 46 divided by 2. So we're looking for the 23rd piece of data. Okay? The 23rd piece of data. So 60 is a reasonable estimate of the median mark because the 23rd piece of data appears here in the 40 to less than or equal to 60 range. And actually the 23rd piece of data could be 60 because of that equals 2. Okay, so we're going to say there are 23 people less than or equal to 60. And we've shown the working out there. Part B. The box plot shows the distribution of marks of the people in Group B. So this is Group B's box plot. For the people in Group A, this is their information. Draw the box plot for Group A on the grid above. So we're using the same scale here, guys. So when we're drawing box plots, you guys need to use a pencil in case you make a mistake. I'm going to use a pen so you can see it nice and clearly. Okay, so first of all, our left whisker, our minimum mark is at 23. So let's have a look at this scale. So 20 to 30, 10 little squares, so each square is worth 1. So 23 is there. I'm not going to use my bubbly part of my ruler. So that's my minimum mark and that's my left whisker, okay? The range is the biggest takeaway, the smallest. The range is the distance from the minimum mark to the maximum mark. So let's do 23 plus 76. So our maximum mark must be at 99, which is here. So that's my right hand whisker. Okay, my median is at 60, which is here. My lower quartile is at 49, My upper quartile is at 75. So what we're going to do now is we're going to draw our box, which is our lower quartile joined to our upper quartile, and our median will be in there somewhere. And then whiskers to join our minimum and maximum values to the box plot itself. So that's the box plot for Group A. Okay, part 2. Make 2 comments to compare the results of Group A and Group B. One comment must include an appropriate average. The other comment must include a measure of spread. Okay, so the appropriate average is the median and the measure of spread is the interquartile range. Okay, so we need to first of all look at the median. So the median for Group A is 60. The median for Group B is 58. I'm going to put that up there. I'm going to put that as Group B so I've got a note of it. Okay, so we can say on average, Group A did better than Group B because their median was 60. Their median marks were 60, and whereas B's was lower at 58. So let's say that. Okay, so on average Group A did better than Group B. Their median was higher at 60 than 58. I'm going to put for Group B to make it clearer. So that's our comment on average. We've dealt with the median. The next comment is the measure of spread, which for a normal data set would be the range. However, when we're dealing with grouped data like this, it's the interquartile range. So we need to find the interquartile range for Group B. Let's write that here. So we want the interquartile range for A and the interquartile range for B. So the interquartile range is the distance between the upper and the lower quartile. So for Group A, 75 take away 49 is 26. The interquartile range of Group A is 26. So the spread of results for Group A was 26. We're going to do the same for B, so we're going to have to read it off here. So we've got our lower quartile at 52, our upper quartile at 72. So 72 take away 52 is 20. So the interquartile range for B is 20. Now, the smaller the interquartile range, the more consistent the data. Okay? So what we can say here is Group B's results were less varied than Group A's because their interquartile range was 20, whereas Group A's interquartile range was 26. Okay, so Group B's results So Group B's results were less varied than Group A's, as the interquartile range was 20, which is less than Group A's, which was 26. So the smaller the interquartile range, the less varied the data. Question 17. On the graph paper below, draw the region which satisfies all of these inequalities. So we have 4 inequalities. We have to indicate clearly the region that is your answer. So we're going to draw these inequalities onto this grid down here. Okay, so a couple of them are nice and easy to do to start off with. So y is less than or equal to 5 and x is greater than or equal to -2. Because they are simply horizontal or vertical lines. So y is less than or equal to 5 is a horizontal line that goes through 5 on the y-axis. But it's a less than or equal to, so because of that equal to symbol, we use a solid line, okay? I'm using a pen so you can see it nice and clearly. Please use pencil in case you need to rub it out. So a solid line, I didn't do very well with my ruler then, but that is y is less than or equal to 5. X is greater than or equal to -2. That's a vertical line that goes through -2 on the x-axis. Again, it's an equal to symbol, so that is also going to be a solid line, because that means that all values on that line can be included as solutions. Okay, so that's x is greater than or equal to -2. Okay, so I'm just going to do some shading now in relation to that, because y is less than or equal to 5. So we want values of y below this line, but we're not interested in values above it. So I'm actually going to shade as best as I can above that line. And then x is greater than or equal to -2. Well, the x values on this side of the line are greater than or equal to -2. Any values on the left-hand side of the line don't satisfy that. So I can actually shade in the left-hand side of the line too. Okay, so I've started to identify a region. The next thing we need to do is draw these two inequalities. Okay, so we're going to plot them as straight lines because they are in the form y equals mx plus c. Okay, so I'm going to start. Have I got a different colour maybe? So for this inequality, I'm using this table just to make it nice and clear, guys. Okay, so all you need to draw a straight line is 2 points. And we want x and y values that correspond to this line. Okay, and we're going to use these x values. So let's start with x equals 4. So if x equals 4, y is 3 subtract 2 times 4. Well, 3 subtract 2 times 4 is -5. Just check that that coordinate 4 minus 5 can be plotted on your diagram. Good. Okay, I need another point. So I'm going to go with x equals 0. So when x equals 0, I'm going to arrow back, change my x equals 4 to 0. That gives me a y coordinate of 3. So I have an x coordinate of 4 with a y coordinate of -5 and an x coordinate of 0 with a y coordinate of 3. You only need 2 points to draw a straight line. Those are my 2 points. So I'm going to draw the line now. But look at the symbol, guys, okay? It's less than, not less than or equal to. So when I draw this line, making sure it goes through those 2 points, it's not a solid line. It's a broken line, a dashed line, okay? So that's one that we've dealt with. Now, we need to deal with the other one. So we are going to do another little table. Again, we only need 2 points to draw a straight line. So we're dealing with this one now. Okay. So let's start with x equals 4 again. So when x equals 4, y is 4 plus 2, which is 6. Can I plot 4, 6 on this graph? 4, 6. I can. Fantastic. So that's my first point, guys. Okay. Now we want another one. So let's do 0 again. Okay. So when x is 0, y is 0 plus 2, which is 2. Can I plot 0, 2 on my graph? Yes, I can. Okay, so I've got those 2 points now. But before you draw the line, check that symbol. It's an equal to symbol, so we are drawing a solid line through those 2 points, guys. Okay, so now we need to identify the region that satisfies these inequalities. We've started to do that by doing this shading. So this broken line here is our y is less than 3 subtract 2x. So less than is on this side of the line here. So we are not interested in anything above that line. Okay, so we can get rid of anything above that line, even if it relates to the other graphs. And don't forget, I'm just going to make this shading a little bit clearer here as well. And we might as well do this one, because why not? Okay, We've still got quite a lot of area here, so we need to check the criteria for our final line that we drew, which was y is greater than or equal to. Okay, so this is our line. Greater than or equal to is above the line. Less than will be below the line. We're interested in greater than, so we're not interested in anything underneath that line there. And what you can see now, guys, is we have a region that has not been shaded, and I'm making it nice and clear by shading darker around the edges that the region that we are interested in, I'm just going to make a little change because I've gone a little bit too eager here when I was shading in this line. So the region that we are interested in is that region there that satisfies all of the inequalities.